Here we're going to review dilating with a center of dilation that's not the origin. We tried to do this a little bit last class. Felt like we struggled with it a little bit. And then a bunch of people are absent today, so I feel like I need to make a video to review this. So I'm just going to go over a couple of these problems, and then you can do the rest on your own. So we're trying to dilate this parallelogram with those 4 points by a scale factor of 1/2 using a center of dilation of -3, -2. So first off, let's just plot the points. -1, 1, 2, 3, 4, 5, 6, 7, 8, that's J. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, that's K. 1, 2, 3, 4, 5, 6, 7, 1, 2, that's L. And then 1, 0, that's M. So that's our original parallelogram. Our center of dilation is at -3, -2. And we're dilating by a scale factor of 1/2. So everything, the distance that everything is away from that center of dilation right now, it's going to get shrunk down by a factor of 2. So let's count how far is J away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 up and 2 over. Oops, 2. Oops, I didn't mean to do that. 10 up, 2 over. We're multiplying them by a scale factor of 1/2. So that's going to shrink down to 5. 1, 2, 3, 4, 5. And the 2 is going to shrink down to just 1. That is J prime. All right, for K, 1, 2, 3, 4, 5, 6, 7, 8 up. 1, 2, 3, 4, 5, 6, 7, 8 over. 8 times 1/2 equals 4. So instead of being 8 up and 8 over, it's going to be 4 up and 4 over. That's the new spot for K. L is not up at all, so it's going to stay on that line. Looks like it's 10 away. I'm just using K. If K was 8, L has to be 10. So 10 times 1/2 is 5. L is going to shrink down to 1, 2, 3, 4, just 5 away now. And then M is 1, 2, 3, 4 to the right and 2 up. 4 to the right and 2 up. Becomes 2 to the right and 1 up. That's our new spot for M. So you can see it's the exact same shape. It just got shrunk down and everything moved closer to our center of dilation. Visually, you could just check that way. Another way to easily check, this will always form a straight line from the center of dilation through the 2 points. So you see, from the center of dilation through J prime through J, center of dilation through M prime and M, center of dilation through K prime and K, and then straight through L prime and L. It will always be that way. It will always form a straight line through your center of dilation and the original image, the original pre-image and the image. All right, I'm going to get rid of these lines so I can record these coordinates. Looks like M is at -1, -1. L is at 2, -2. K is at 1, 2. J prime, should really be saying prime, but -2, -3. Oh, sorry, +3. Right, I'm going to do one more of these. Got triangle WXY. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 13, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, I think these are 15, so I'm just going to drop that down to there, -13. All right, that's our original triangle. We're going to use a scale factor of 1/3 from a center of dilation of 1, 2, 3, 4, negative 1. Alright, so we're going to count how far everything is away from that center of dilation. It's 3 down, 3 over for W. 3 down, 3 over becomes 1 down and 1 over. Multiplying each of those times 1/3. So that's where W prime ends up. X is 1, 2, 3, 4, 5, 6, 7, 8, 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9 over. 9 times 1/3 is 3. So now it's going to be 3 down and 3 over. Actually, that's where W started. And Y looks like it's 3 more down, which means it's 12 down. That's going to become 4 down. And it's 1, 2, 3. Oops, sorry, I was counting from there. 1, 2, 3 to the left. That becomes 1 to the left. So 1, 2, 3, 4 down, 1 to the left. That's where Y prime ends up. That's our new shape. 1, 2, 3, 4, 5, negative 2 for W. 7, negative 4 for X. And 3, negative 5 for Y. Alright, so that's how to actually do the transformation. On the back, we're talking about going backwards. So there might be an algebraic strategy for solving for the center of dilation and the scale factor. I mean, there is for the scale factor pretty easily. You just figure out the length of that side and how the original side compares to it. So you can figure out the length of that side, and divide and figure out the scale factor. However, I think it's just easiest to do this visually. We know that we can draw a straight line from L to L prime through the center. So I'm just going to draw that line through these 2 points and just continue it. I can also draw another line through M and M prime and continue that. And then N through N prime and continue that. Where those 3 lines meet, that has to be the center of dilation. So our center of dilation is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 1, 5. Then I'm going to think about how much further or closer they get away from this center of dilation. So my original point is 1, 2, 3, 4, 5, 6 above. The new point is only 3 above. We went from 6 to 3. That was multiplied by a scale factor of 1/2. Let's do one more of these. I'm going to pick number 8. I'm going to draw a line from R prime through R, S prime through S, and see where those meet. I would definitely use a ruler for this. These need to be straight lines. You're not just trying to guess. You can also double check to make sure once you think you have your point, but I would definitely use a ruler. Like, obviously I have an advantage here using the smart board. I can draw directly straight lines, but using a ruler definitely helps here. So I'm looking at where that point is. 1, 2, 3, 4 over, 3 down. That's 4, negative 3. R originally is 3 to the right. R prime ends up 6 to the right. It went from 3 to 6. That's a scale factor of 2. All right, try the rest of these on your own as practice. If you need help, ask for some help.